Here we go. All right, so graphing calculator. Well, no, we'll get to graph calculator in a minute. Let's start off. So this one is a table. The table shows the purchasing power of $1 in various years. Use the first and last data points. That's an important part of this the writing. Use the first and the last data points to find an exponential function and use it to determine when the purchasing power of the dollar will drop to 40 cents. Right? So you know how the dollar gets weaker and weaker over time. So I guess what $1 now would have bought $1 previously. Anyway, so all I care about, I'm just going to show you the math. First and last data points. What's that mean? This one, those two numbers, and this one. First and last. So I'm grabbing the first entry in the table and the last entry in the table. I'm going to use those two tables. The idea is this. It's exponential. So it's like if somebody said, okay, here's the years down here. The years are like the x-axis. This is like x, the years, and the y's are like the purchasing power, the what it can buy. And basically what we're going to see is it's going to go like this, the graph. But how we're going to approximate it, we don't know that at first. They're going to say, hey, it's exponential, and I want you just to use the first dot and use the second dot, and then make an exponential curve that fits those two dots. Now, I don't mean, we're not going to show any graphs, or, well, at the end we'll use the graphing calculator, but I just want to give you the picture idea behind what we're mechanically going to do with the equation. You get the idea? They're basically saying, hey, this thing's exponential. What does exponential mean? They either grow like that or shrink like that. This one's shrinking. The purchasing power of the dollar is dropping. And so they're giving us 2 points. This is 1983 up at 1.06. And do that with you. All right, so here we go. Going to go to the graphing calculator. Type that stuff in. Turn that on. All right. Graphing calculator. Go up to Y1. I'm getting nothing on that screen up there. Which one is it? This one? I'm getting nothing. Is it this one? I think that's it, but it's not. Oh, one that says Elmo. I labeled it. Okay, it's going to come on in a second. I have confidence. Yes, all right. Here we go. See, okay there? I can't really see that screen very well, can you? My overhead thing's not on. How do you do that? There we go. All right. I'm such a tech expert, man. All right. So the Y1, what is the Y1? 0.40. So just literally put in 0.40 into Y1. Oh, I had them reversed. Doesn't matter. Whatever. Y2, you could switch them. It doesn't matter which one's which. One of them, just one of them be Y1, one of them be Y2. So the other one is 1.06. What was it? 0.93. 02. Is that right? That's right, isn't it? 939302. 939302, yeah. To the power of t. How do you do that in a graphing calculator? Up arrow. See what I'm going to push here? It's up arrow button. That's to the power, at least on the TI it is, of t. We see this big button right here? This is for all graphing. This is the x, the t, the theta, the whatever, for all your, just use it. See, yeah, but it's an x, not a t. Whatever. It's all the same thing. It's just the graphing calculator. This is the letter I use for the independent variable, for the x-axis when I graph. Call it whatever you want. That's the one you want. So that's your x, your t, your whatever when you're graphing. So everybody see what I got then? I put one of the functions in y1, one of them in y2. You could switch it. Doesn't matter which one's y1, y2. Okay? And then you hit graph. There's the flat one. That's the 0.40. And there's the exponential one. And we need to find where they intersected. Now, mine came in all beautiful because I made the window right before class. So you might not be, the issue, the hard thing with these are not simple. You do need to spend some time. If you show up on game day, exam day, and having not practiced, that's just like, my son just started a little junior high baseball team, and it has been raining so much. They've had like 2 practices, maybe 3. They got a game like tomorrow. Anyway, that's not going to go well. They're just going to show up and hack around out there. But anyway, don't you do that on on graphing calculator test day, right? You want to practice with this thing's a tool. You need to practice with this thing a little bit. So the main thing that's hard is the window. So if you have a window that's not right, you're not going to see this. Now, how do you know what window to do? Let me give you two big hints. If you're seeing nothing, if you got like nothing on your window, try to go big. Like my window, let me tell you, my window is 0 to 30 and 0 to 1.5. See how I just hit the window button up here? Hit window, at least on the TI, and I said it's 0 to 30, 0 to 1.5. Why? The normal standard window is negative 10 to positive 10, negative 10 to positive 10. We don't want negative values. Whenever you're doing math, you want to keep one foot in reality along with the other foot in your math problem. What's reality here? What is it we're even talking about? What is x? That was funny. What is x and y in this problem? What is x? I mean, real life, what is x? A year. It's a year. Like 1983 or something. X is years. It can't be negative, in other words, right? Don't put any negative numbers in there. Right? And what's y? It's purchasing power. Again, not negative. And how big is y again? What's the biggest y you're looking at? Just over 1. We don't want to go to 10 or 100 or 1,000. See how y? So always look at your table and say, what about are my x values? What about are my y values? And set up a window that's right around that neighborhood. And you'll get a good picture. So my x values, no, not 1983, remember? The x values are the years after 83. You guys know what I'm talking about? So the x values, really this x value is 0. Whoops, not on my writing thing. This x value is 0. And this one is 12, and the other ones are numbers in between 0 and 12, huh? Remember, it's years after. That's what x is, or t, or whatever you want to call it. It's not the 1983 itself. It's those years subtract to 1983. It's years after 1983. So anyway, my point is x goes from 0 to 12. Y goes from a big of 1.06 to a small of 0.5. So that's kind of how you want your x and y window to be. X window's got to be like 0 to 12, or, I mean, 20's fine. You know, just something, just don't make it 5,000, you know. You won't get a good picture. So, all right, so let's go back then. So what I'm saying is that's why I set my window. So I went 0 to 30. Really, I would have been better if I just did like 0 to 20 or whatever. And my y, I went up to 1.5. I only needed to go to 1.06 or whatever, but that's fine. Graph. And what we're looking for is that point of intersection. So you guys getting a good picture on your screen now? Okay, now how do we find a point of intersection? It's real easy. Second calc. Have we done it? We've not done any of this before, have we? So you hit second calc. Like that. Go down to intersect. You see that? I'll write this out in a second. Second calc. Go down to intersect. And hit enter. And it's going to say first curve, second curve, guess. Don't even waste your time here. Let you see what I'm doing. There. Okay, you can see everything. I'm going to hit enter. I want you to see my finger down here. I'm just going to hit first curve, enter. Second, see how the cursor's on the second curve now? It doesn't matter. It'll always do the right. And it says guess. Who cares? Just hit enter, enter. My point is hit enter, enter, enter. And boom, it finds the point of intersection. There it is. 15.56. X is 15.56. Y is 0.40. Right? Yeah, because y is 0.4. That's right. Remember, we hit it 40 cents. That was the y. So the x is 15.56. So that's our x. That's years after 1983. So we're going to have to add that to 1983 to find the year. Does that make sense? I'll round that to 16. 15.56, round to 16. Is that true? We'll see. We good to there? It's good? Are we happy with that? I'm going to go back now to the other screen, and I'll write down those steps. Questions?
Okay, so mine just did x equal 15, so that's okay.
15 or is it 15.56? No? Are you guys getting like straight 15? Maybe I typed mine in wrong. Did I make a mistake? 939302 to the x. 1.06. Looks right. Double check that if you're not getting that. Anybody else getting the answer I got?
It came up right this time. It came up
15.56.
Okay. You're getting what I got?
15.6.
You guys getting that okay? With the intersect. Let me show one more thing. Some people think they can just move their cursor around and just get on it like that. That's not going to work, guys. You can't just move the little mouse thing and go, oh, I'll just move this. This is easier. No, that's just approximate. You're not getting the real. Now this, see, it says it's 14 point. It's not right. That's just approximate. You can't just move that little mouse thing. You've got to do that one more time. Second, calc. You do that, calculate. Go down to intersect and hit enter, enter, enter. Boom, 15.56. And it finds that. All right, so let's go back to the other screen and give the answer we got. So we got T, or X, or whatever you want to call it, 15.56. Now, what does that mean? What does that mean, 15.56? Well, that means, remember, what T is years after 19. Remember, T is 0 was 1983, right? So that's got to be 1983 plus 15.56. So what's that going to be? 1998.56. 1998.56. So what is that? Is that 1998 or is that 1999? Well, I'm not sure what they're going to do. If they're being good about it, what was their question? The purchasing power of a dollar will reach 40 cents in the year. Yeah, the answer is going to be 1998. I'm not going to round that up to 1999. The reason is the 0.5 means like halfway through 98. You know what I mean? 1998.0 would be January 1st. And 0.56 is like a little more than halfway through the year 1998, like July or something, right? It's early July. So that's just a little more than halfway through the year 1998. So that's still in the year 1998. Does that make sense? Which is what they asked me. Power of dollar, which went in the year. In what year? So in the year 1998. Now, having said all that, let's go back and type it in and see if that's true. Okay, so there we go. So, all right, so they're giving me this function. It has been found that a worker new to the operation of a certain task on the assembly line produces this much on day T. So you got to be clear what the variables are. P is what they produce. T is how many days they've been on the job, right? So, and then they're asking, how many items will be produced on the first day? The worker will produce blah, blah, blah items on the first day. So let me write the function. P of T equals 23 minus 23 e to the minus, what is that, 0.2? T, am I reading that right? Yeah, negative 0.2 t. So there's the function. They're asking how many items will the worker produce on the first day? How am I going to answer that? The main thing, guys, all these, so this class requires a little bit of, we have a lot of word problems. And so you gotta kind of get the hang of them. And what I mean, what the hang of them is watching the units. I survived physics with that. Just pay attention to the units. First day. What letter is days? T. So they're saying to me, first day, day 1, T1, aren't they? They're saying plug in T1. You see that? See how I came up with that conclusion? That's what you got to learn to do on word problems, because they're not. This is a more advanced class. This isn't algebra. This is college level. Fresno State will take this. Any university will take it. So it's more mature. They're not just in algebra. I teach algebra all the time. I just give them cookie cutter. I show them one kind of word problem, and then there's 10 the same. And they don't even have to really read them. Just boom, 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 answer. Boom, 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 answer. That's because it's not college level. Right? This is college level. They're going to change them up every time. You really have to read them and really get the meaning out of them. So days are T, first day, that's T is 1. So so they're saying, oh, okay, you just want me to plug in 1 for T, like that. That makes sense? Plug in 1 and hit the buttons on your calculator. You guys have your graphing calculator? Can you type that in? Is it 4? Come in 4. So if you have trouble with that, I'd be glad to help you after class. Hang out, I'll show you how to type that into your graphing calculator. There's an E button that you use. Basically, you type in I could just say, I'll say this much, 23 minus 23 e to the power, well, it kind of depends. Your e to the x button kind of does the power automatically on most calculators. So just hit the e to the x button, and then the negative 0.2. Yeah, I'm not helping. Just type in what you see, basically. Type in what you see. If you have trouble with that, I'd be glad to help you after. So 4. That good for the first question? You guys getting that? Is anybody else getting 4?
Yeah, like 4.169.
Yeah, 4.16, so 4.169, and they say round to the nearest whole number. It says right here, so 4 on that. Okay, now that's the first question. Now they have another question, and that is, what is the maximum number of items? What's the maximum number? How do we find the maximum number of items? Graph it. We got a graph. Find max by graph. So take a graph, put in y1 equals, well, this, well, with a t anyway. So y1, just type in y1 equals 23 minus 23 e to the minus 0.2t. Type that into y1, hit the graph button, and see what you can see. Are you ready? So let's go to it. Let's look at the original question and just ask ourselves, what are the typical x's, what are the typical y's? What should we be looking at? Well, let me see, the x's, what are the x's? The x's are the t's, and they're the days. So again, not negative, huh? So the t's, or x, should be like 1, 2, 3, maybe up to 100 at most. 100 days of work, you know, to see how they're doing. And then what is the p? P is the y. The y is the p, right? The function is the y. What is p? Yeah, units produced. What's that going to be? I mean, I don't even know, but it looks like there's numbers like 23. It's in the 20s, probably. So I'm thinking the t is like 0 to 100. The p is up in the 20s, maybe. I don't know, something like that. Let's go back and see what we can do. So I'm going to go to my window. Hit window. I'm going to go, what was t again? 0 to maybe 100. And, oh, so my y was too low. I only had 0 to 1.5. So I need to have 0 to like 25 or something. 30 maybe. All right, let's graph. There we go.
How do you know to put 25?
Yeah, what I did there, going back, I did 0 to 100, 0 to 30. It's because of what was back in the original. Yeah, I didn't really, say it very clear, did I?
No.
Looking back here, looking back here at the, you're not supposed to agree with that. You're supposed to say, no, Mr. Heron, you said it so well. All right, so looking back here, I just know exponential functions, so I don't know what to say. I'm just looking at that thing, and I'm thinking this. So I don't know if this is going to help you if you're very comfortable with exponential functions. I'll just write it out here. I'm just looking at that thing, and I'm thinking, if I plugged in a 0 there, if I let t be 0, what would that be? Well, I don't know if you guys know this or not. That'd be e to the 0, right? What's e to the 0? What's anything to the 0 power? 1. That's all 1. So it's 23 minus 23. It's 0. Oh, yeah, that doesn't help, huh? That just came out 0. Yeah.
You're just going to guess, or what?
No, well, just look at that front number. How about that?
Okay.
Yeah, I'll just give you that rule for now. We're going to get into exponential functions like a week or two. We'll be doing a lot more exponential functions. Then I'll be able to say, hey, based on what you know now, basically this number in the front, yeah, let's just say I just looked at that 23 and I thought, it's around the 20s. It's around the 20s. So going back to the graphing calculator, it's around the 20s. So that's why I set my y values from 0 to 30, so I'd cover the 20s. And I hit graph. All right. Anyway, why are we doing all this? What are we even supposed to answer here? Maximum. What's the highest it looks like that thing's going? Well, somewhere way over here. Let me go. I can use my cursor now. Even though I said don't use it for intersection points because it's not that precise. But if you go over here, how high is this? Yeah, it looks like I'm about 23. 23.2. That's the y height there. It looks like it's 23.2. it's maxing out at that height, isn't it? Around 23. That's what we're seeing on the graph. Okay, let's go back over here and say, looking at this function, it must be maxing out. The max is about 23. They'll just ask you for a whole number. I wrote 33. The max is 23. It's going to max out about 23 on that. That graphing calculator cursor was off a little. It's really not going to ever get above 23. The 23.2 was false. It doesn't get above 23. We'll talk about exponential functions later. But good enough for the graphing calculator. I just moved the thing over there, and the height was around 23. They just asked for a whole number, so 23. It really is that number in the front. That's as high as it's ever going to be because this is subtracting stuff. So anyway, we'll talk about exponential functions later. All right, guys, that's a lot of detail. So let's try this one. Okay, so I'm going to kind of do this one quick if it's okay with you, even though it's a little complex. So they give me this formula. So I'm just going to call it y is t0 plus cb to the little t. There's a difference here between that capital T and the little t. All right. Notice that T0 is the constant temperature of the environment. A cup of coffee is cooled from 95 to 50 after 15 minutes at a room at 25. The 25 is the capital T0. The C, I don't know. Let me just fill in the T0. So the 25 is the environment. It's the room you're in. Right? Basically, the cup of coffee, whatever temperature it's at, will start moving towards the temperature of the room, won't it? This is Newton's law of cooling. Right? We sense that, right? Take a cup of coffee into the refrigerator, it'll start moving towards the temperature of the refrigerator. And over time, you leave it in there a couple hours, it'll be the temperature of the refrigerator, won't it? If you leave it out in the kitchen, then after a couple hours, it'll be the temperature of the kitchen. It'll start moving towards the temperature in the room it's in. So that's the capital T0, 25. Now, they're saying it went from 95 to 50 in 15 minutes. It went from 95 to 50 in 15 minutes. What did it start off to be? Oh, 95. Yeah, okay. See what they're saying? It starts at 95 degrees, doesn't it? Isn't that what they're saying there? It went from 95 to 50. So it started at 95, didn't it? That coffee was poured at 95 degrees, right? So what? What does that mean? That means starts. Starts means what time? Time 0. They're telling me when t is 0, y is 95. Do you see how I'm coming up with that? That's the kind of thing you got to learn to do to survive in this class with the word problems. You got to be able to read the words and put them into reality. I know that's not easy. That takes time. I'm glad to help office hours. Roberto, our tutor, will help. It takes time. It's not going to come to the casual. So they're saying when time is 0, the temperature is 95. Well, how do you know y is temperature? Well, the F of T, it says right there, Newton's law of cooling, the formula is but where F is the temperature. And I let y be the F, right? The y is always a function of it. So that's the temperature, according to the words. F is the temperature. The y is the temperature. So the temperature is I'm going to put 95 here and 0 there. They go together. At time 0, the temperature is 95. Right? You guys tracking with how I'm thinking? How I'm seeing that? So at 95 degrees, when time is 0. Right? Everybody see that? What I did? You can get lost in this. Like, what am I even trying to do now? Well, I need to get the formula. Do you know what it means when somebody says, get the formula? I've noticed a lot of people are confused by, if you don't do a lot of math, science, you're like, what do you mean, get the formula? I mean, catch this, guys. If I've been doing the 1-1-1 Charlie Brown, dial in now. Get the formula means get everything but the x or the t. That means find the T0, the C, the B. Get everything but the x or the t, or whatever it is. That's what it means to get the formula. Does that make sense? Everything but t. The little t here, not everything else but the little t. That's like our x. That's always there. Does that make sense? That's always what you do in these problems, is you get the formula. which means find out all the other letters except for the T. Have it ready to go. And then you go on and answer their last question. So I won't even think about answering their 40-degree question. I won't even look at that until I've got the formula, which means I have everything but the T. How do you get that? Well, I start looking at the data values they're giving me and start plugging stuff in. So they told me the room is 25. I looked at the words and went, oh, that's T0, constant temperature of the environment. So boom, that's T0. Then I went, oh, I got to get C and I got to get B. How am I going to do that? I don't know. Look at some fact. Oh, started at 95. Times 0, 95. Put in 95, put in times 0. Now, can that help me get something? What's anything to the 0 power? 1. So that's 1. So that's C times 1. That's just C. B's gone. So I can solve for T. Subtract 25. What's that? 70 is C. C times 1 is just C. C is 70. Got my hands on C. Let's go back to the formula. So I've got 25 for the T0. Now I've got 70 for the C. All I've got left is to get B, and I'll have the formula and be able to answer the last question. So you see what I'm doing? You see how these work? This is all phase 1 right now. Phase 1 is getting the formula. Doing whatever it takes, plugging in different points to get your hands on the formula. So all I've got, I found capital T0 because that's the temperature of the room. I found the C by plugging in time 0, temperature 95. Got my hands on C. 70. Now, how do you find B? Is there any other facts I haven't used yet? 50 degrees after 15 minutes. Remember, they go together. There's always a temperature and a time. Just like 95 degrees was time 0, they went together. 50 degrees is what it is at time 15 minutes, huh? Right? So plug that in now. So now, plug in 50 degrees at time 15. See how they always go in together at the same time? A time and a temp, a time and a temp. Or in the last problem, whatever it was, a time and a purchasing power. They go together. It's like an X and a Y. All right, I can solve that for B now. It's not easy, but we can. Subtract 25. Well, that's 25 from both sides. Divide by 70. 25 over 70. What's that? Some 3.35714. What? 0.3571428 equals B to the 15th. How do we get B?
Times 1 divided by 15.
Raise both sides to the 1/15th power. Right? Then we'll have B. Then we can try to answer the final question. These are a lot of work, aren't they? So I'm going to move to a new screen and get B here. So where are we at? So we're Y equals T0, which is 25, plus C, which is 70, B to the T. I plugged in the 50 degrees at time 15 minutes. Let's kind of recap what I did real quick. 15 minutes, subtract the 25 from both sides. 70 B to the T, divide by the 70, and I got that number, 0.35714, 35,714, 285 is B to the 15th. Then you raise both sides to the 1/15th power. At that point, and so then you get B equals whatever your calculator says. And I'm getting 0.93386. 86. No, 66. No, is that right? Is it 66? I can't see on my screen here. 66. 661566. That's 6615. So that's enough accuracy. 6615. So I got B. I've got the formula now. I've got every letter. So what's the formula? Y equals 25 plus 70B, which is 0.9336615 to the T. Can you read that? I'm getting scribbly there at the end. Is that good? We've got the formula. Now we're ready to answer their last question. We found every letter by plugging in data points. So what's the last question? How long will it take to be 40 degrees? Okay, where does, now you got to be clear, where that 40, where's that 40 go? What letter is that? It's a temperature, which we decided was Y. Because they said up here, the function is the temperature. Y is always the function, huh? So the temperature is 40, so they want me to put the 40 right there. So they're saying 40 is 25 plus 70 times 0.9336615 to the t. How am I going to solve that? Graphing calculator, yet again, right? Let this be y1, let all of this be y2. Hit the buttons on your graphing calculator. I'm not going to go through that again. Just put that on your graphing calculator, graph them both, find the intersection. Use the intersection routine on your graphing calculator. Can you tell the difference between my plus sign and my t? This is plus, and this is t. Like that. We good?
So on the window here,
Uh-huh.
how would we do that?
Yeah, so you just got to look at reality on that. So think with me. What are the x's, or the t's in this case, and what are the y's? What are some typical numbers you're seeing for x or t? What is x? What is t? T is time. What time numbers are we talking about?
15 minutes and higher.
Yeah, we talked about 15 minutes, and then we talked about later. So maybe you could go like 0 to 60 minutes. That'd be 1 hour at most. 50 minutes, 40 minutes. All that's probably fine.
And we're typically just changing the maxes, right?
Well, you don't want the mins to be negative. I don't know if your calculator has mins that are negative. Yeah, I don't know what your calculator was set on before.
It was basically just like yours.
Okay, yeah. So, well, the initial settings are -10, +10, so you don't want any negatives. So you would change the mins. And the y values, what is y again, real life? Y is temperatures. And what are the temperatures? Well, I'm looking at a 95. That's the highest. So 0 to 95. Or 100 if you want. Does that make sense? See how I come up with real life on that? So windows in that zone.
Or you go 25 to 95.
Yeah, you don't have to go to 0.
Because the room's 25 degrees.
Right, you could do 25. It doesn't have to be exact. It's not exact, guys. It's just you have to be in the neighborhood. You don't want to be like 10,000 or only going up to 3 or something like that. Anything in the neighborhood, 0 to 100, 0 to, probably 0, 100, 0, 100 for both would work fine. You know, you'd see the graph fine. So, just you can't be like way off. All right, these are time consuming. Okay, so they give me this function. So they're giving me f of x equals 73.6 over 1 plus 16 times 0.8428 to the x, like that. All right. Let's see how you're doing at reading word problems and knowing what to do. See if you can, let me give you a second. See if you can figure out what to do based on what they're saying and what their question is. So they're saying something about 47 million. I want to ask yourself, is that x or is that f of x? There's only two things, right? Is it x or y? X or f of x? It's number of subscribers. Well, what's number of subscribers? Number of people who subscribe by f of x, yeah. So 47 goes there. Equals that whole thing. Does that make sense? It's not x, it's f of x, it's y. Because it's number of subscribers, and they said that was f of x. X is the years, with 0 being 1970, huh? See that up there? That's not what they're asking for. Well, I mean, that is what they want in the end. They want the year, but they're giving me, so I'm not saying that very clearly. They're giving me 47 million subscribers. They're asking me what year that happens in. So that's graphing calculator. Let this be y1. Let this be y2. Do the intersect on your graphing calculator. And what should be your window? The x is the year, How many years are we talking about? I don't know. 0 is 1970, so maybe go from 0 to 50 at most, probably. 100 if you really want to go crazy. Y, 0 to, and what's Y subscribers? I'm looking at 47 million, and they're going up from there, huh? 47 million is going to go up from there, so you better go up to like, I don't know, you better go up to at least 100, maybe 500 on the Y. Because it started off with 47 million subscribers, and it's going to climb pretty fast probably. I don't know, maybe 100 would work. I don't know. I'm just guessing. Try 500, try 100, until you get a good picture. And you want to know, oh, we just want to know where it's 47, huh? No, we just need to go to 50, huh? 50 is good enough. Yeah, just 0 to 50, huh? So 0, 50, 0, 50 should work on that. And you want to find the intersection. We good? I'm going to keep moving if that's okay. Okay, so log 0.1 equals -1. They want me to write it some other way. So we're talking logs. So we're starting a log section here. So how do you do it? Let me just give you the basic rule for converting logs. Here's what it is. So if you have the log base b of, I don't know, whatever you want to call it, w equals z, that converts this way. So let me just write a sentence. When you lose or gain a log, here's what happens. Well, I don't need steps. I'll just say the base stays the base. The other two switch. The base stays the base. That says stays there. The base stays the base. The other two switch. Now, what am I talking about? What's a base? It's this guy, right? It's the low down part. When we talk about like the base of a table, we mean the bottom, right? So when we talk about the base of a logarithm, we mean the number that's low, number, letter, whatever, the thing that's lower down. Logs always have a lower down part. You guys have had intermediate algebra, right? I can assume a little bit. I don't remember any of that stuff. I hope you remember a little. I mean, I'm starting from the ground floor, but I'm going to move kind of quick. So grab me if you're having trouble. The base is the low down part of a log, right? The log has a lower, that's lowered down on purpose to make you, remind you that's like a base. Now a base is something, so it looks like it's b to the w power, doesn't it? It's made to look that way. It's actually the reverse of that, but it's made to make you think of that kind of thing. A log is a reverse exponential. That's what it is. So look at that low down number, and you say, oh, and by the way, let's go back to our log. This log here, he's got no low down number. So what is it if there's no low down number? 10. 10. You guys had intermediate algebra, right? Giving you a hard time. All right, 10. So if there's no log showing, it's 10. It's called the common log. So if there's no base showing, the base is 10. Base is 10. Okay, so what do you do then? So let me rewrite it down here. So log base 10 of 0.1 is -1. So you're supposed to, when you lose, look what it says. When you lose, or gain, we're not gaining, we're losing. When you lose the log, so I'm going to cross off that log word, I'm going to lose it. Bye-bye log word. When you lose the log, the base stays the base. Like the 10 will continue to be the low down number. He'll continue to have a power on him. Right? That's what it means to stay the base. He's still the base. He's still the bottom. He's still going to have a power on him. But the other two will switch. So these two will switch. Instead of 10 to the 0.1, it's 10 to the -1. And the 0.1 goes over there. So the base stays the base. When you cross off the log word, no more log word. When you do that, the base stays the base. The other two switch. And that's all they want. They just want you to practice rewriting it first. We didn't actually solve anything. We just translate. It's like going 1, uno. I just said it in a different language. That's what I just did. The log was saying it in his log language, and now this exponential language. So there it is. Is that good? Let's try another one. We have a little bit of time. Okay, so 1 is log base 3 of 3. So So lose the log. So they want you to translate, which means cross out that log word. Base stays the base. Other two switch. Give that a try. How y'all doing? So working out? Lose the log word. Base stays the base. Who's the base? The low down three. The other two, meaning those two, right? Because the base is here. He stays a base. He'll continue to have something on him. The other two switch. Instead of 3 to the 3, it's 3 to the 1, and the 3 goes over there. Now that's a no-brainer statement, huh? 3 to the 1 equals 3. Well, the log is saying, that's what I was saying all along in my language. And now we're saying it in power language. Same truth, said in two different languages. Does that make sense? With a log and without a log. Want to try another one? Okay, so e to the second power is 7.3891. Now this time, they want me to bring in a log word. There's no log there at all. So I'm translating the other way. I'm going from uno back to 1, right? I'm translating languages the other way. I'm going from regular power language, exponent language, to log. There's no log here right now. They want me to bring in a log. It's the same rule. Nothing changes. Right? Remember how I wrote whether you gain or lose a log word, base stays a base, other two switch. So now I'm going to gain. I'm going to put on a log word that was never there. Same rule. What happens? Base stays the base. He's the base. I mean, you better lower him down. He continues to be the base, but the what? The other two switch. Instead of e to the 2, it's e to the 7.3891, and the 2 goes over there. I'm going to do one more small thing. Does everybody see that? It's the same exact step. Whether you gain a new log word that wasn't there or you lose one that was there, base stays the base, other two switch. But now, what is log base e? We have a special phrase. It's right there, huh? It's ln. What does that stand for? ln? ln, those of you who passed intermediate algebra, I'm just giving you a hard time today, huh? It's a prerequisite. Natural log? Natural log. Now, it's said backwards. It's logarithmic natural. You know how they put the adjectives after the nouns in Spanish and French and languages like that, right? It's French. But anyway, whatever. Logarithmic natural. Natural log is what it is. So that stands for natural log, meaning it's a log base e. So ln is a shortcut for log base e. ln is a shortcut. You guys have seen that, right? Intermediate algebra? I don't expect you to be masters, but you've seen that, haven't you? ln is log base e. So basically we have two understood bases in logarithm world. If they show no base at all, that means log base 10. It's called the common log. And if they show no base with the ln, it's log base e. So there's two logs that don't show their base, but really have a base. Every log really has a base. There's no such thing as a log without a base. They all have a base. It's just in two cases we don't show their base. It's just because they use these so often. Like anything else in life, when you do the same thing a million times, after a while you say, look, I'm not going to write the 10, all right? That's, in the real world, they use the 10 so often when they do things with logs that they just stopped showing them. They said, look, if I just write log and I don't show any base, I mean 10. If I write ln, I mean the special number e. E's a special number. I'll see, like pi is a special number, 3.14 or whatever. E is a special number used in calculus to do certain things, so it's special. So this is our final answer, because log base e becomes natural log. All right, try that one. Did I do roll? No, let me do roll, and then you